on this meeting, and later this evening I will send you a link that lets you watch the recording of this session. And
okay.
every time I record all my sessions, and I always post them as quickly as I can. I'll try to get it up this evening. It might be tomorrow morning. It takes my computer a while to process these files after they're recorded in the GoToMeeting format.
Okay.
Now, there's one thing we still have a choice on what to do, and that is, how do we access that site that you were on today that gave you your problems, your homework problems?
Mm-hmm.
We can do it two ways. You can either send me, copy and paste the link and send it to me. There's a chat window, you'll notice, in that GoToMeeting where you can send stuff back and forth. And I'll open it up. I'll need your username and password, and then we'll both be looking at it on my computer. Now, the other way we can do it is you can just go to it on your computer and tell me what the question is. This morning we saw the first question and it took an hour and a half to answer it. So I'm thinking that we may be just doing one problem in our half-hour session.
Well, I actually, that was a concept that I didn't understand this morning, and my brain was a little bit fried from lack of sleep. I took the quiz over that section. I did decently on the quiz on that section. I got a 94 on the Chapter 2 quiz, but I have a couple more like specific questions. I'm copying and pasting
if
the...
you have specific questions that you can verbalize to me, then let's do it.
Yes, actually...
Let's do it that way, because it can be a pain for me to log on to your website. Interesting. I'm getting a text. Oh, no. GoToMeeting has changed slightly. And I'm getting messages from you that look like they're text messages.
So I sent two screenshots that I've had on my computer that are basically questions or things I don't understand, and then I also sent you the login and my password. And
here's the thing: if you send them to my phone, I can't really bring them up on my computer. When you're going to send me stuff, if you can send it to my email address, that's the more direct way to do it.
Okay.
I see, let me write my email address. It's a little, this is the more direct one. The one on my digital math tutor website doesn't get to me quite as quickly as this one does. It's davidcowan1949@gmail. If you can figure out how to send those screenshots to that email address, that's probably the best way to go.
Okay. Yeah, that's great.
And then that might take a minute or two for me to get an email with an image in it. So is there anything you can verbalize that we can kind of be working on while we're waiting for that?
Yes.
Okay.
There was one part of the quiz that threw me off. I understand the all the different functions and everything we were talking about earlier really well now.
Good. And
my one question that I got wrong and didn't understand was if it's multiplied, it's a vertical, I forget what they're called, translation?
Yeah,
not
translations and reflections. Translations and reflections is what we covered today.
So the vertical reflection, and it's something like y equals -2 quantity of absolute value of x. So I flipped it, and I would think that because it's vertical and because it's a whole number, let's see.
Okay, let's talk about this function. First of all, this is one of the elementary functions, absolute value of x. Okay.
Okay.
I would say my
no, sorry, I didn't word the question right, but it's a specific question about just this. If it is a -2, is that going to be a shrink or a stretch? I don't want to go into, because I know the details of other things, but there's like one detail.
It's in front of the function, right? If the parent
Yes.
function is absolute value of x, this is all in front, which makes it a vertical reflection and a vertical stretch. So let's talk about what that means. First of all, let me graph the parent function. That's what y equal absolute value of x looks like. Okay? So I'm going to do two things to it. I'm going to reflect it vertically so that it looks like this now. That's the first thing. And then I'm going to stretch it by a factor of 2. Well, let me draw the stretch in blue. Here's what the stretched would look like. Notice that every one of these points is twice as far away from the x-axis because each point is being multiplied by 2. And the net effect of that is you have a stretching of the function as if somebody was pulling down on that function. Did I answer your question?
Yes, that makes a lot more sense.
Okay. Now, let's see. Did you get that email off? Let me check my emails.
I actually, no, I can't, I haven't gotten an email sent to you, but
it might be that you can verbalize everything. With algebra, usually that's the case. If you were taking geometry, it'd be a whole different story. You'd be sending me graphs, objects, and stuff that I would need to look at. So I would need you to send me those kind of questions. But as long as they're questions that you can verbalize, that's actually a better way to do it. You do learn something by being forced to verbalize a problem. So what else do you have?
I actually, well, not sending. I want to drop these files to send them because it's not going to be possible for me to describe them to you, even though I know it would be good.
So how are you trying to send the screenshot?
I'm dropping them in the email. I've done this before, and it will typically work.
Okay. Once you get my email typed in there, the next time you do it, you only have to type in the first 2 letters, and it'll remember it. So you're only going to have to type in this long email once, and it's worth doing.
It sent that, so that is good.
Okay. Let's make sure. There it is. All right. Let's see here. Let me scrunch that back up there. Graph the function, and it's a piecewise function. Okay, that's what these are called. It's where when x is less than 0, it's one function, but when x is greater than 0, it's a different function. Can you see that from the graph?
I actually am trying to pull up the picture now. I have a lot of pictures on my screen.
Well,
can you tell me,
just look at my screen. In other words, if you...
I think I have, does it say quiz chapter 2 on it?
Yeah.
Or is it a...
Well,
okay.
example 2.
I didn't know
the first one I've got about here. Oh, the bottom one is quiz number 2. I see that one now also. It's, you want to start with that?
Yes, and that's partly the same kind of issue that I was asking about the negative number being a stretch or...
Okay. Let me see if I can blow this up a little bit. I think I can. I'll see if my computer will read this file. Yeah, sure. Okay. Still getting a little used to a new operating system myself, Windows 10.
Okay.
All right, so the figure below shows the graph of a function. Doesn't tell us what the function is, just shows the graph of it. And they want us to sketch minus 1/2 of that. So what's the minus going to do?
It's going to flip it over the x-axis.
Okay, and of the 4 graphs we're looking at, A has been flipped over the x, B has been flipped, C has been flipped, D has not. So it's A, B, or C, okay? Now, what's the significance of the 1/2?
That is 1/2 is less than 1, so I would have thought that it was would be shrunk.
Correct, and it is.
But
it's a shrink factor. So, in other words, if I point, I don't know, can you tell where I'm pointing?
oh no, I'm actually looking at my screenshot. Let me.
It's better if you look at mine. In fact, it's almost always better if we're both looking at
I'm looking now.
Okay. You see this point where I don't know, can you tell where I'm pointing with my cursor?
I'm looking for it.
Way over on the left. Here, let me click their arrow here.
Oh, it's a screenshot, so you can't.
That's not going to work. Okay. But anyway, see that point? The point I'm pointing at is -3 -4 on the graph on the left. Okay. Well, that's going to be flipped over the x-axis and shrunk by 1/2. So, and it's the vertical. So it affects the y-coordinates only. So the new point is going to be -2 +2. The point that was at -3 -4 is first of all going to be flipped over the axis, putting it at -3 +4. You with me?
Yes.
And then it's going to be shrunk in half. In other words, it's going to get halfway closer to the x-axis. So it's going to come down to -3 +2. So that's where that point needs to be. Well, if I look at my choices over here, on the right, which one has that point at -3 +2?
The C.
Not sure you can tell from mine because the scale is so small. Maybe, let me blow it up a little bit. Yeah.
No, it is. Yeah, I can see that. I didn't think of the -3.
It looks to me it's B, because notice it's halfway between the grid there. Oh, but this one also is halfway, so C could be right.
C is correct. I marked A, but C is correct.
Well, here's the reason I made a mistake is because I didn't notice that each grid in C was 2 units, not 1. In other words, all 4 of these graphs that we're looking at here, every grid mark is 2 units, both horizontally and vertically. So if I'm looking for 3, -3, +2, that's it right there at C. And A doesn't have it. A would be -2, +4. B would be -3, +4. So the only one that represents this adjustment is C. And the only thing you really have to do is find a point and send it through these adjustments to see which one works. Not all points work. Notice that the 0 point doesn't tell us much. In other words, if we were to look at the vertex of that M there, that's at 0, 0. Well, when you reflect that, it doesn't move. And when you shrink it, it doesn't move. So that point is going to be that point on all the graphs, including this one. Notice the 0, 0 point. We wouldn't want to use that to figure out the adjustment. You see why? When you reflect 0, it doesn't move. And when you shrink it by half, it doesn't change. It stays right there at 0, 0. And so that point is at 0, 0 in all 4 pictures.
Okay.
Okay? Make sure when you do these, you do the reflection first and then the vertical shrink.
Okay, I'm going to write that down real quick.
Always do any reflections first, whether they're horizontal or vertical reflections. You've got to do your reflections first.
Okay.
Okay, now you want me to open up the other page?
Yes, that sounds great.
Oops, hold on. And that's this, hold on, let's see. I've got, oh, no, I can blow that up. Yeah. That's probably big enough. You can see that?
Yes, yeah, I can see it.
Okay. So here we're talking about piecewise functions. Okay? These give people quite a bit of trouble, but they really shouldn't. What it really is just multiple functions on different domains. In other words, if you look at the graph, you can see that whenever x is left of 0, the function should be 2x plus 3. Well, that's a linear function. That's a straight line with a slope of 2 and a y-intercept of 3. So it goes through that point. It's got a slope of 2. I don't know if you can see where I'm pointing, but I'm pointing to the graph that is only to the left of the y-axis, which is where x is less than or equal to 0.
Okay.
Okay.
Yeah.
Now, if we look at the bottom part of that, now we're looking where x is greater than 0, so everything to the right of the y-axis, and I can see that that's a parabola. That's quadratic. It's x squared. And it's a quadratic that points down because of the negative sign. In other words, a normal quadratic that would just y equal x squared would point up. So whenever there's a negative sign in front of it, it means it's been reflected and is going to point down. But you can see that that's half of a parabola. Only half because it's only this to the right of the y-axis. Now notice where the points meet. Right there. Piecewise functions, they don't always have to meet. In other words, I can have a piecewise function that looks like this. And it's just as common. In fact, more common. You're more liable to see a piecewise function that looks like the following. And this piecewise function might be something like this. F of x equals, that's got a slope of 1, maybe goes through the point 5, so that would be x plus 5. Whenever x is less than or equal to 0, and it's equal to, and they usually use this thing like that. They don't use the double equal sign, so let me erase that. But they use this squiggly thing, usually with piecewise functions. And the function on the right is just x squared, whenever x is greater than 0. And notice how they don't meet at the same place. It's not a continuous function. The function that we were just looking at is continuous. And continuous is important in a lot of senses, but the easiest definition of continuous is if I have to pick up my pen to draw it, it's not continuous. Well, I had to pick up my pen to draw this one. There's no way I could have drawn this thing without lifting my pen at that point and going down here and starting it again. As opposed to what we were looking at, which was something like that, well, I can draw that without lifting my pen. And I don't really even need that dot since they're on the same point. That is the piecewise function we were just looking at, and there's a difference in that that's continuous. Most piecewise functions you're going to come across are not going to be continuous. They'll look more like my blue drawing than the red drawing. The secret with piecewise functions is to always start there. In other words, what's that saying is that when I look at this part of the graph, I'm going to graph x plus 5, this line right there. And when I look at, in other words, notice that I'm dividing this graph up by domain. When I look at this part of the graph, I'm going to graph x squared because I'm to the right. So the way you want to do these is to look at them vertically, basically. Should we do one more example just so, yeah, let me write one where...
I actually, no, I feel confident in.
Okay.
For sure. There's another one.
We don't want to waste time doing stuff you already know. What else you got?
Yeah. I wanted to ask you about like notation. So they have, can I draw on here or no?
No, you can't. I actually have a drawing tablet that I have attached to my computer, and it has a special cursor that allows me to draw on it. Unless you had the newest Apple that maybe lets you draw on your screen, and then maybe there's a way to do it. I just don't know how. The two best ways to get problems to me is either to be able to verbalize them or take a screenshot and send it, just like you did before. That might be the best way. That worked out pretty good, actually.
That makes sense. I'm trying to think of how to verbalize this because I don't actually know.
Tell me what you're looking at. Maybe I can help without seeing it.
I'm looking for the example because I don't know. A lot of times I've gotten problems wrong because I use the wrong type of parentheses.
Okay.
Here's one other thing.
There's one other thing I can do with GoToMeeting. I can toggle it so that we're both looking at your screen. And if you want me to do that, I can do that right now. I think I can. Yeah, hold on a moment. They've changed this, so I have to figure out how to do it. Let's see. If I click on you, yeah, make presenter. Now you're going to have to do something on your end. And remember, I'm going to be looking at your screen. So you should have gotten a message. Go ahead and click OK. There we go. Open up what you want to show me, and I'll see it. Yeah, there we go. Okay. Is that it? Is that the right problem?
Actually, I had not pulled it up. I'll try to find homework with what I was thinking of. The main issue is just like knowing what kind of like brackets or something else to use. So
well, brackets and parentheses are the same thing, really. The only reason you use brackets instead of parentheses is because it makes it a little clearer. Notice that in this problem right here, let's have a look. Back up one. Notice, determine the domain and the range of the relation. Okay, and then tell whether that relation is a function or not. And they use bracket and then parentheses. And the only reason they do that is because it's clearer to read. They could have used double parentheses and it would have had the same meaning. So there's no difference between a bracket. Unless you have a bunch of them together, you know, you can have parentheses inside of parentheses inside of parentheses. And then you're sitting there staring at 3 parentheses and it's hard to figure out what you're looking at. So a lot of times the outside set of parentheses, they'll make brackets. And they'll either use a bracket sign or this little squiggly mark right there.
I'll try to find one because the teacher, it may be specific to the professor or the course, but
let's talk about domain and range, because we haven't talked about it yet, and it's a big subject.
Oh, I feel confident with domain and range.
What's that? Okay. I saw the X on this problem, and I figured maybe.
Because I've spent like 10 hours a day, like really studying it. But whenever, like, so if you look on the screen, whenever it asks, like, what is the domain?
I see. You have the answer. Yeah, okay, and that's correct, okay. Okay, now here's the question maybe you're asking, is when to use the bracket and when to use the parentheses?
Yes,
This is a little different.
No.
When you're giving interval notation, which is what this is, type your answer in interval notation. A bracket means it can actually be equal to -1/4. A parentheses would mean it can't be. It would have to be greater than -1/4. So it's essentially the same difference as the difference between greater than or greater than and equal. Notice that -1/4 is okay here. If I plug in -1/4, I'm taking the square root of 0, which is permissible. You just can't take the square root of a negative number. Okay. Here, let's see. We're about done. Is that correct?
About done.
We're going to do a half hour tonight, or?
Yes, a half hour tonight, and then I need to schedule a half hour tomorrow night.
And I'll let you do that, and I'm completely open tomorrow night after 7. So.
Okay.
Let me switch back to me being the presenter just for a moment so that I can show you something. Okay, you can see my screen now?
Yes, I can.
Okay. If I were to say this, what's the domain?
The domain is 0 to infinity.
Correct, which I could also write like this. You gave it to me in interval notation. Okay, let me write it in interval notation. 0 is okay, so I can use a bracket. And parentheses always go next to an infinity sign, never a bracket. Okay? Now let me change the problem just slightly. Now what's the domain? Can x be 0?
No, but it can be 1.
Well, it can be great. It's got to be greater than 0. So in interval notation, I'm going to use a parentheses instead of the bracket. So it's still 0 to infinity, but it's surrounded by parentheses because it can't be 0. It could be 0.00001. In other words, it can be a very, very small number. It just can't be 0. And that's the difference between that bracket and that parentheses. In this case, it can be 0 also. In other words, it has to be is greater than or equal to 0. But in this case down here, because you cannot divide by 0, x can't be 0. You would be dividing by 0 if you let x be 0. So that's the only difference. In other words, down here, if I wanted to write this without interval notation, I would say x has to be greater than 0, not greater than or equal.
That makes sense.
This answer is permissible. This is interval notation. This is interval notation. This answer means the same thing.
Okay, and what's the difference between, so there's interval notation and another kind of notation, I forget what it is. Do you
Well,
know what that is?
there's a bunch of different kind. Interval notation allows you to spell out multiple intervals. Let's say I had an interval where the answer was 0 to 2, and then it was in combination with 3 to infinity. Well, that means it can't be between 2 and 3. It can either be between 0 and 2, or it can be 3 to infinity. And that's interval notation allows you to write that properly. The other notation that you run into frequently is this notation where you would say x is equal to all reals except perhaps couldn't be 3. So that's another notation similar to interval notation. How would I write that in interval notation? Exactly like this: minus infinity to 3, parentheses, because it can't be 3, in combination with 3 to positive infinity. So that means the same thing as that. It can be every number except 3.
Got it. That makes sense. So it could be 3.1 or 2.9?
Exactly.
Okay. I had, can I ask a clarifying question? Because that's exactly what I was wondering with one of the questions. One of them had, it asked about the domain, and it gave a continuous line that went across the y-axis, and so it crossed, and there was a filled-in circle on the, like, it would be at like 0.
A filled-in circle. Okay.
And so it could be 0, and I gave the answer negative infinity to positive infinity, like parentheses, negative infinity, comma, just like that. And then it said no, because it needs to be negative infinity to 0.
What I've drawn on my page here, to figure out domain, is all you really have to do is look at the graph and look at the x-axis. Well, it can be anything from negative infinity. Can it be 0? Yes. Can it be 0.00001? Yes. And does it go all the way to positive infinity? Yes. That's the domain of what I just drew.
Right. So I gave that answer because I spent several hours on it, and it marked it as wrong. So is that just like maybe it was something different?
It's hard to tell.
It confused me because I thought I understood it.
It's hard for me to say because those programs are so flaky in how they want your answer. Let's talk about that problem tomorrow night. Maybe you can show it to me. I'll make you the presenter. You can bring it up. Maybe it was a case where that was an open 0, perhaps?
Yeah, I could have missed that. I just, that was something that
if I draw it like that, and it's open at both ends, well, now the domain is not negative infinity to infinity. That open 0 means it cannot be 0.
So it would be 0,
negative infinity to 0,
square brackets, right?
with 0 to positive infinity. Or you could say all reals with the exception of x equals 0.
Okay, that makes sense.
Yeah, it all depends on whether these are open or closed. You rarely see this. It's just not what you typically see. Usually one of them is closed. In other words, it could be this one down here or that one. And it makes a difference because this one down here, the function at 0 is equal to 0. Whereas if I change it and make the upper dot closed, well then the function at 0 is equal to whatever that value is, say 5. Whoops, if I make it closed and leave this one open, then if I said, well, what is the function value at x equals 0, you'd have to go look at that point right there.
Okay.
Okay, Whitney. Well, like I said, I will process this and I'll try to get it up to you by tonight, but it might be tomorrow morning. And then I will send you an email on the email that you put when you signed up, and send you a link that will allow you to watch this video. And what you're going to watch is everything that's on the screen plus both of our voices, and that's it.
Yeah, that's a really neat system.
Yeah.
I appreciate it. Thank you.
It works great, really. So you're welcome, and I will probably talk to you tomorrow night. Now, when I call you tomorrow, I won't call you tomorrow night. I will just text you the meeting ID number, okay? At this point, you should have an icon on your desktop that looks kind of like this yellow flower here, or orange flower.
Yeah, I saw it earlier.
The way you'll want to start tomorrow night is after you get the meeting ID number from me, texted, just double click that icon and put that meeting ID number in. We'll be in the meeting. You don't have to do anything more with the sound. It'll default to the right setting. Just takes those two actions.
Okay.
Okay?
Perfect.
So I will talk to you tomorrow night after texting you the meeting ID number.
Okay. That sounds great. I appreciate it. I'll talk to you then.
Okay. Bye-bye.
Bye.